Today we will calculate the additional moments that results from the column slenderness and then compare the results with that obtained from Etabs. We will first determine if the frame should be considered as non-sway or sway based on stability index. The stability index can be expressed as, for a braced frame, it's common for the stability index to be less than 0.05 because the braces provide significant stiffness to resist lateral loads, reducing displacement. The value of stability index depends on the axial load, the lateral displacement, the horizontal shear, and the height of the structure. For the first story, the story is braced, and for the ground story, it's also braced. Cylinder columns can experience increased deflection when subjected to lateral loads. So first we need to understand whether a column is cylinder or not. To calculate the slenderness ratio for the column, we will first obtain the effective length factor K that consider the end conditions and restraints of the column. We need to compute the degree of the end restraint at each end based on the following relation. Based on the degree of end restraint and the frame classification, effective length factor can be computed based on the alignment charts. From the chart, the K value equals to 0.875. Now we will check the slenderness ratio for the column. The maximum ratio for a short column in a braced frame is 40. The computed value was 47.1, so the column can be considered as a cylinder column. Moments of the first order analysis should be modified to include the slenderness effect. Calculate the moment, magnification factor, and the magnified moment based on the following relation. The SM factor is typically used in braced frames to refine the second order analysis by adjusting the effective slenderness or magnifying moment due to axial forces, and it's equal to. According to the ACI code, the effective value of EI can be determined based on any one of the following relations, but the Etabs uses a different formula to calculate the effective value of EI, just by multiplying the real value by 0.25. The buckling load equal to 2380 kN. The moment magnification factor equals to 1.5. That means that the primary moment that computed based on the first order analysis should be increased by 50% to include the secondary moment. Now we will check the results.